Today we're going to be talking about inverse functions. To have an inverse, a function needs to have two things. The first thing is it needs to be a function. How we determine if certain things are functions is called the vertical line test, which you guys should have done in Algebra 1. The second thing it needs to have an inverse, it needs to be 1 to 1. And for it to be 1 to 1, it needs to pass the horizontal line test. Alright, so we look at our first example, and we graph just the relation. Okay, so we graph negative 10, 10, negative 10, 0, 0, 2, negative 3, and 10, negative 2. So if we graph all those points and check first if it is a function by the vertical line test, as we can see, if I draw vertical lines through all my points, it never hits. The line never hits more than 1 point, so it is a function. So protocol 1 is covered. Next thing we're going to check if it is 1 to 1. We're going to do that by the horizontal line test. Again, it never hits more than one dot, so it passes the horizontal line test, meaning it is 1 to 1. Therefore, it has an inverse. To find the inverse, all we're going to do is switch the x and y values. So instead of it, it's still negative 10 for the first one, 0, 0 for the second one. For a third point, just switch x and y, so it's going to be negative 3, 2, and negative 2, 10. So if we plot the next one really quickly, just so I can show you. So this relation is a function because, again, it passes the horizontal line test, but it is not 1 to 1. If I draw that line, it hits a point, or it hits more than 1 point, so it's going to fail 1 to 1, so it does not have an inverse. So just no inverse. Alright, so if we graph that, the best way to graph that would be in your graphing calculator. Pull that up. So I'm going to plot just the graph from the last question, which was 3x squared minus 6. I'm going to change my window back to standard. If it's already standard, you don't have to worry about it. So there's that graph. So I'm just going to sketch it on so I'm just going to sketch it on ours. Alright, so I go down 6, 1, 2, 3, 4, 5, 6. There's my graph. Alright, again, this is going to be a function because it passes the horizontal line test, but it is not going to be 1 to 1 because it's failing at all of those points. It's hitting more than once on that graph. So this also has no inverse. Alright, now let's look at line. We graph this line, go 4, and my slope would be a 4 over 1. So there's that line graphed. Now let's look at this line. Is this a function? Yes, because it passes the horizontal line test. I'm sorry, the vertical line test. Is it 1 to 1? Yes, because it passes the horizontal line test. So it only hits in 1 point on the graph. Therefore, it has an inverse. To find the inverse, again, I just switch x and y. I'm actually going to switch x and y in my equation this time because it is not points. So I'm going to write x equals 4y plus 4. To solve for the inverse, I'm going to solve for y, so I'm going to subtract 4 and divide by 4. So I'm going to get y equals 1/4 x minus 1. Now we have a special notation for the inverse, so I'm going to replace y when I have my inverse with f to the negative 1 of x, and that is just notation. It has nothing to do with solving the problem. It's just how we denote the inverse. So there's the inverse. Another one. Oh, here we go. All right, so this one's actually going to be a special case we're going to look at. So if I graphed it, you are more than welcome to graph it on your graphing calculator. It looks like this. All right, my domain, which is my possible x value, is only greater than 0. So it does not exist to the left because my x values are negative to the left. So there's what my function looks like with a domain of 0 or greater than 0. It passes the vertical line test. It passes the horizontal line test. So it has an inverse. To find the inverse, again, I'm going to switch x and y. So I'm going to get x equals 4y squared minus 8. To solve for y, I'm going to add 8. And I get 8x plus 8 equals 4y squared. Divide both sides by 4. And I get y squared equals x over 4. X over 4 plus 2. Take the square root of both sides. So I get y equals x over 4 plus 2 square rooted. So that would be the inverse. If I graph the inverse on a different coordinate, you're more than welcome, again, to put in a graphing calculator. I'm going to go 8. So there's my graph of the inverse. Again, put in your graphing calculator if you're unsure. Okay, so we need to talk about the next thing on inverses. If I look at my domain for the original function, oh, and I've made a mistake down here. I always, again, denote my inverse as f to the negative 1 of x. So that's really what I want to put as my answer. Alright, so if I talk about the domain of the original function, the domain we were given is x is greater than 0. Again, domain is a possible x values. My range would be y is greater than 8 because my possible y values are 8 to infinity. Notation, if you want to write it like MathXL likes you to write it, this and this. Okay, so let's talk about range. Let's talk about our inverse function. Our inverse function's range is going to be x is greater than 0. Again, my possible x values are all x values greater than 0. And my domain is going to be y is greater than 8. I'm sorry, x is greater than 8. Again, domain is saying, ooh, messed it up over here too. I'm sorry, my range is always my y values. So my y values are greater than 0. Domain, my x values are greater than 8. So I just want you to notice my domain of my original function and my range of my original function are the same except for x and y being flopped, which makes sense because to solve for the inverse I switch x and y. Also my range for the original function and my domain
for the original function or the inverse function are also the same except for switching x and y. Okay, so we got to do logarithmic functions really quickly. We have 2 more examples to look at. So to find the inverse of a logarithmic function, I'm going to take the logarithmic function and switch x and y. So it's going to be x equals log base 5 over y minus 2. Alright, now I'm going to write it to, I'm going to solve for y, so to solve for y I need to write it as an exponential. So it's 5 to the x equals y minus 2. And then I need to add 2 to both sides. So I get y equals 5 to the x plus 2. Again, notation is going to be f negative 1 of x equals 5 to the x plus 2. Okay, so last one, this is an exponential. Its inverse is going to be a logarithmic function. Again, to find the inverse, I switch x and y. Now I solve for y. To solve for y, I'm going to, this is actually a little trickier. I'm going to divide by 4. Divide by 4. So that's going to cancel. So x over 4 equals 2.7 to the y. I'm now going to write that as a logarithm. Again, my base, we talked about 100 times, is 2.7. So it's log of 2.7 to the x over 4 equals y. Again, I need to fix my notation, so it's going to be log of base 2.7 of x over 4 equals f to the negative 1 of x. If you have any questions on MathXL, email me. I know there might be some issues, so don't be afraid to email me, but you need to get this lesson done to the best of your ability, which means I'm expecting you, unless you email me, to complete all but one of the questions.